Okay, let's get to Chapter 3, Section 2, Inverse Functions and Logarithms. So again, this is a review topic from college algebra. Remember that logarithmic functions were already covered prior to this class, so if you need to go back, review logarithmic functions and inverse functions. Some of the properties of the graphs: if you have a logarithmic function, f of x equals log base a of x, or log of x base a, and where the base is bigger than 0 and not 1, then the graph of this looks like this red curve if the base is bigger than 1. So what happens here is, as x goes to infinity, the graph slowly but surely keeps rising and rising and rising. I can zoom out here a little bit. You can see that it goes out to infinity. It's a slow growth, but it does grow. And then as x approaches 0 from the right side, our graph takes off to negative infinity. And of course the logarithm doesn't exist over here. So we have two limits here: x going to infinity, function goes to infinity. X approaches 0 from the right, function goes to negative infinity. Now if we let the base be a number that's less than 1, then what we're going to get is this. So it kind of flips it over the x-axis. And now as x goes to infinity, your function approaches negative infinity. And as x approaches 0 from the right, you approach positive infinity. So those are the basic characteristics of logarithmic functions. Some of the properties. Again, every logarithmic function is continuous on 0 infinity. So on its implied domain, these are nice continuous functions. And then here are some log properties. If you take log base a of x times y, you can split this up into two logs with addition. If you have log base a of x divided by y, you can split it into two logs with subtraction between the two. And this is a real nice property. If you have log base a of x raised to the r, you can pull the r out in front, so the power on the x comes out, and you have r times log base a of x. Those should be review topics from college algebra. Now, the base that we were saying here for an exponential function is any number bigger than 0 but not 1. If we choose the base a, okay, if we take this base a and we choose it to be the very, very special number e, all right, then what we get is the natural exponential function, f of x equals e to the x. Remember, e is about 2.718. You know, it keeps on going forever and ever, non-repeating, non-terminating decimal. But when we use that as a base, we get our natural exponential function. We'll be talking later about what the properties of this are. Then, if we take the base a again to be e for a logarithmic function, we get what we call the natural log function. So it's log base e of x, and instead of writing this, we have a shorthand notation. We just write ln x instead. So here are some properties of these two special functions. If you take the natural log function and compose it with the exponential function, these are inverse functions, so they wipe each other out basically, and what you get is x. So if you plug a real number in here, put these two together, that real number is going to come out. Here, it's supposed to be the other way around. Oops, this is a typo. I'm just going to fix this. There we go. If you take e and compose it with natural log of x, so this time you take the natural log of x and then use that as the exponent of e, again they wipe each other out and you get x. The only condition here is that the x we plug in has to be bigger than 0, because the natural log function can't handle negative numbers or 0. So we do have a little domain restriction on this equation or identity. E to the 0 is 1, and that's because any number to the 0, well, any non-zero number raised to the 0 is 1. Natural log of 1 is 0, and natural log of e is 1. So those are some special properties that you'll need to remember. Also, we have what's called the change of base formula. Let me make this a little bigger for us. If anybody gives you a logarithm, log base a of x, no matter what the base is, no matter what x is, you can always change it into this. So log base a of x equals natural log of x over natural log of a. And the power of this change of base formula is that it allows us to figure out any logarithm for any base using our calculator, because our calculator has the natural log key on it. So just keep that in mind. Special formula, we'll be using that sometimes, and these properties sometimes. If you need to, again, go back and review anything from college algebra, I would encourage you to look at inverse functions and then go back and look at the logarithms.